storing the data, another part is for storing the address of next node. So that's why already we discussed about how to construct a single linked list and even the structure of the single linked list also we discussed. Even insertion we are already started. I think we can insert linked list in 3 ways: insertion at beginning of the list, insertion at end of the list, insertion at specific location in the list. Now, in this insertion at beginning of the list is completed. Is it completed? Is it visible?
Yes, sir.
Yeah, insertion at beginning is completed. Insertion at beginning of the list is completed or not?
Yes, sir.
Completed is total.
No, sir. No, sir.
No, I think we are created a node and we are allotted memory and we are inserted value and null value, right?
Yes,
Yeah.
sir.
I think this much we are completed. This one means structure node, and it means new node we are going to create here, correct? Because that node structure already we are created, it contains 2 parts. Here one is for data part, another one is for storing the address of next node. Here that is NN, right? We have declared that struct node as NN. That's why it is NN, right? Now here memory is allotted, using malloc function. Is it clear, malloc function, everyone?
Yes, sir.
Yeah. Here we are allotted memory for that. Even we are entered data using printf scanf methods. Now, NN of data, we are going to store the data, read the data using scanf method. Maybe I am entering here 10. Now it is going to store it NN data. That 10 is stored in NN data part. Now, NN next part we are assigning with null because we are not attaching anything. That's why it is initially it is null. Now our new node is ready, correct? Yes or no? In continuation of last class, our new node is ready. Is it right?
Yes, sir.
This is clear, right? Right. This is clear, right? And then next part, and then node data part. Is it clear? Is it clear, everyone? Is it clear? Any doubt is there in this code?
Sir, can you explain once again this whole program
Which one? This first one?
from starting onwards?
No, in the last class you are not presented or absent. No problem. Because I am going to explain any number of times for the single linked list. Because here, if you are going to understand single linked list, following data structures, you can understand very easily. So that's why please listen, everyone. People who are, if you are absent or you are not followed in the last class, please try to concentrate again. Here already I told you, in a single linked list, here every node is divided into 2 parts. One is for storing the data, another part is for storing the address of next node. So that's why here single linked list structure is like this. As per the last class, previous classes discussion, here this node is connected to next node is connected to next node is connected to next node. Here because every node is having address part, this address part is going to store the network address. Here like this, we are going to connect. And two important points also we discussed in the last class. Here always the single linked list start from first node. Here we can represent that first node as a start node or a header node. Here and always the single linked list ends with the last node. Here then how to represent the last node? Here the last node in the single linked list, the node address part contains, this next part contains null. Then we can conclude that node, the node which contains next is null. Then we can conclude that node is a last node. Now clear about single linked list structure?
Yes, sir. Yes.
Yeah. Now this is the structure. Now how to implement? For implementation, we have three operations: insertion, deletion, display. Right? Here first operation is the insertion. Here we can insert a node in three ways: insertion at beginning, insertion at end, insertion at specific location. Means we can insert beginning means first node. You insert new node as a first node, or you insert that new node as a last node, or you can insert new node as anywhere in the middle. Here, in the three ways we can insert. Here, instead of writing only one big program and big logic, you people are going to confuse. Here, that's why I divided my program into different three methods, three functions. Here, insertion at the beginning, insertion at the last, insertion in anywhere. Even if you are going to refer your textbook, they will write only one area. In other books, some people will write in only one area to insert everything. Here, that you are going to confuse. That's why I categorize it into three categories: okay? Beginning, last, and anywhere. Then you can understand very easily. Initially, you can understand how data structure is going to construct. That's why please try to understand, try to follow my scenario. Then you can easily implement. Once you are going to understand, then you can do anything. Then you can read any textbook or any material also. You can easily understand. Okay. Now insertion. First operation. Insertion at beginning we are going to do that. For that, when we are going to insert, first of all, you have to construct ADT. Here, this is the first task because here this abstract data type, single linked list, is not a predefined data structure. It is we are going to construct our data structure. When you want to use integer, no need to construct anything because it is already predefined data structure. So that's why you have to prepare a abstract data type. Yes or no?
Yes, sir.
Yeah. Now we have to prepare our structure because if you want to use that structure, compulsory you have to prepare because that structure is not existed earlier. Now, what is the single linked list node structure? ADT, abstract data type. Already I told you, node is divided into two parts. Node is divided into two parts, right?
Yes,
Or
sir.
no? Yeah. So the first part is for storing the data. The second part is for storing the address of next node. That's why we have to prepare a structure program for creating a structure of your node. Okay, that's why in structure name I am taking node. You can take any name, not a problem. Structure name. That is a node I have taken. Now first part is for storing the data. What type of data I want to store, you declare that is which type you want to store the data. Then I want to store integer data in the data part. That's why I have declared a variable which is integer type. That is into data. You can change your data, you can change your variable name also, not a problem. It is as per your requirement. Are you clear now? Are you clear? Yeah,
Yes,
this
sir.
is a structure I am preparing. This is structure only. This is not a node. Here we are preparing node structure. So we are not allotting memory here. Just we are thinking here I need this type of memory block. This type of memory block, and it must be accept this type of data. So this is we are giving information to the compiler. Compiler is going to request to the operating system because this type of node, it is not predefined. One, we have to create. That's why the user-defined data structure. Please note this point very clearly. Okay, whenever you have to prepare your own data structure, you have to prepare a structure. That is an abstract data type you have to prepare. So after preparation of abstract data type, you can use the abstract data type wherever you want in your program, like integer float, how we are using. The same way you can use. But here you must, before that you must be prepared the abstract data type. In that way, I am preparing the structure. Means I am preparing the memory block, how to use, how to work this, how to analyze, and how to prepare. Here in a single linked list, the block, each node must be required two parts. That's why the first part is integer. The second part is going to store the address of next node. So that's why I prepared this node name. Whatever the name you can take, you can take. This pointer I am taking this, you can take any name, not a problem. You know anyway. So now this is the integer type. The variable name is I have taken data. So this is another part. That is for next. It is going to store address of another node. Then it is a pointer which is going to store address of another node. Means whenever we have to connect it to any node, means we are connecting means we are storing the address of that node in this pointer. If we are connecting to any node means storing address means which node address we are storing, node address we are storing. Here node is which type we don't know we are declaring. Node is which type, struct to node type. So that's why indirectly this next pointer is which type, struct node type. That's why I have declared this next pointer as a struct node type. Are you clear?
Yes, sir.
Now structure is prepared. Very clearly structure is prepared. Now initially there is no node, there is no structure, right? Initially when we are going to run your program, initially from beginning, we are not allotted any memory. At the time of starting of program execution, there is no structure. Yes or no?
Yes,
Yes or
sir.
no?
Yes.
Sure, that's why I create one object for this struct node. That is a start. I have created one object for this struct node. So that is a I am taking start is the first node in a single linked list. Initially there is no structure. That's why here for this object I am assigning null value. That's why start is equal to null. In this inside of structure I am assigning. If you don't want to assign inside of the structure, if you want to assign outside of the structure, then you write, you put semicolon here, after the bracket you put semicolon. After that we have to write struct to node start equal to null. Clear this? Clear this?
Yes, sir.
Yes, sir.
Yeah. Now node structure is ready. Abstract data type is ready now. Now you can use this abstract data type. Okay, wherever you want. Clear this? Clear this?
Yes, sir.
Now I want to insertion. I want to apply insertion operation. Here we already told you can insert in the three ways. Here at a time we can write all the logic in the same insertion. You will get confusion. So that's why here I classified into three ways we can insert. One way is inserting at the beginning of the list. Second one, inserting at end of the list. Third one is the insertion at a specific position of the list. Now, first way we are going to discuss today. Today means now we will complete today insertion operation. Please follow. Insertion at beginning of the list. Here, how to insert the element before the beginning of the list. Here, this is the list. Here, we have to insert before this. Means first, your new node as a first node. We have to work like that. We have understood this point. Insertion at beginning of the list.
Yes, sir.
Yeah. Means first element means one queue already existed. You are going to stand in front of that queue. So that is we have to arrange. So like that. Okay. Right. If you want to insert now the node we have to create, right? But what node you want to insert? That node you have to create. Yes or no?
Yes, sir.
Yeah. Structure is existed, but you are not created. For example, here structure is existed already. You are directly creating NTA a equal 10. You are writing. Yes or no? If you want to use that data. Yes or no? Yes or no?
Yes, sir.
But in this user-defined data type, structure we are created. Now this structure, now you can think structure is existed now. Now you want to use this structure compulsory, you have to create. But here structure only there, but we are not allotted any memory. Yes or no? That's why you have to first of all initialize that particular structure. You must declare that first particular structure. What structure I have taken? Struct to node structure I have created. This is struct to node. Yes or no? That's why struct to node NN. Here now I am creating a structure here. Are you clear? Are you clear this? When I am writing struct to node NN, what happened? Here NN is a new node I am creating which contain which structure? Struct to node structure. What is the struct to node structure? That block is divided into two parts. One part is for data part, another part is for next point. Are you clear this?
Yes, sir.
Okay, I declared one variable for latter purpose. You can understand later. Okay, now new node is created. No new node is there, but memory is not assigned. Right, this particular new node. Yes or no? We are not allotted any memory for this new node. This particular memory block, this structure.
Yes.
Yes or no?
Yes, sir.
Now we have to allot the memory dynamically. Means now I want to use this NN, then I am going to allot the memory. If I don't want to use, structure is created, we are not allotting. Yeah, this is the logic. Generally, when we are going to use predefined data structures, sure, whenever you want, you are not thinking about the using or not using. Just we are going to declare automatically memory is going to allot. Yeah, that is the big problem. But using this mechanism, we are going to use dynamic memory allocation. Now, I am going to insert this new node in a beginning of the list. Now I am going to use. If I am using, then we have to allot the memory. Here, then how to allot the memory? Here using malloc method, memory allocation method in C programming, we are going to allot the memory for the new node. Then how to allot? You know malloc method syntax. Simple malloc of size of whatever the size we are going to specify, you can specify. But here, this new node size we don't know because it is we are going to create for our purpose. That is why whenever we are using, then memory is going to automatically decided by operating system, this dynamic way. So that's why instead of specifying number here, you are going to specify that particular node structure. So that is malloc of size of structure node. Are you clear? Are you clear up to this?
Yes, sir.
Right. Now NN is which type? NN is structure node type. If NN is structure node type, here compulsory the memory must be follow structure node type. Yes or no?
Yes, sir.
Here that is the reason. Here explicitly you are going to convert structure node type. Now completely when we are going to allot the memory, we have to write NN equal to structure node of malloc of size of structure node. Now this is clear? Is this clear?
Yes, sir.
Yeah, now memory is allotted. Now memory is allotted, then you can use it for your purpose. That's why here we are going to insert the data. Here this is only memory allotted, structure is created, memory allotted. But you are not inserted data, you are not given any pointer variable here. Yes or no? Yes or no? Yes or no?
Yes, sir.
So that's why you must ask end user, enter what data you want to insert. That's why printf statement, enter data. Here, after entering, you have to read the data and insert here in this location. What is this location? NN, NN next location. Yes or no? NN, this is NN next, right?
Yes, sir.
NN next. As per the structure, you know, NN, sorry, NN data. This is as per the structure, NN data. Okay, this is NN data. This is NN next. Clear? Clear?
Yes, sir.
Now NN data. Now the end user is going to enter integer data, right? That's why 10 he will enter. 10, 100, whatever the integer data you want to enter. Enter 10. Then when we are going to enter 10, it is going to read the data. We are going to insert the data. Where we are going to insert address of NN data. Then NN data. Here what is NN data? This is the NN data. Now 10 will be inserted in this NN data. Are you clear now? Are you clear now?
Yes, sir.
Now after data is there, now later we have to insert this particular next part, NN next. Here initially NN next, what is the NN next? We are not connected to any node, right? That's why we are going to initialize null here. That is the reason here, this is the statement, NN next equal to null. Correct? You don't need to ask to end user because anyway initially this node is not pointing to anyone, it is not connected to any node because we are creating a new node. Yes or no?
Yes, sir.
Now new node is created. Now you can insert this node wherever you want. Okay, this code, this up to this code is common for insertion operation. If you want to insert beginning, if you want to insert last, if you want to insert anywhere. This code is common. I will show you this code everywhere. That's why I don't want to discuss again this code in insert at last, insert at anywhere. Are you clear now? That's why I told you 90% of the code we can use every time. Are you clear now?
Yes, sir.
Yes, sir.
Right, node is created, right? New node is created, right?
Yes, sir.
Right, new node is created. Here our task is we are going to insert a node beginning of the list, beginning of the single linked list. Yes or no? Yes or no?
Yes, sir.
Now, one point you tell me initially the single link when we are going to run your program, the single link list is existed or single link list is empty. The single link list existed or not existed initially. So, for example, if you want to take it movie ticket, you are morning 5 a.m. That queue is existed or not. If I take
Yes,
that
sir.
is initially,
Yes,
the
sir.
queue is existed.
Yes,
Sir, morning 5 o'clock in your classroom, anyone is there?
No, sir.
No. Means the list is existed or not?
yes, sir.
Initially, initially list is existed or not? Initially, single link. When you are going to run your program, your single link list is existed or not?
Yes, sir.
Yes, sir.
Yes or means existed or not?
Existed.
Single link list existed anytime. That single link list existed anytime. Anytime you consider anytime your class contains students.
No, no, sir.
Then how you are telling every time the single link list is existed? Yes or no? Initially means starting. No one is there. Sometime after some time, all are came out. That time also no one is there. We don't know the students are existed or not. But sometimes existed, sometimes not existed. Two possibilities are there or not.
Yes, sir.
Please, please understand the situation. Two possibilities are there or not.
Yes, sir.
Clear everyone? This point is clear everyone? I'm asking everyone. So this type of logic only you can understand. This type of thinking is required to implement the logic. So we don't know. Sometimes the list is existed. Sometimes the list is not existed. These are the two cases. Yes or no? Yes or no? Yeah. Sure, but we don't know exactly the list is existed or not. Even the one element is there in the list also we can tell list is existed. Two elements are there in the list also we can tell list is existed. N elements are there in the list is existed. Means here as per the discussion, previous discussion, the 2 points already I told you. In a single linked list, the address of the first node is always stored in the reference node known as front are also sometimes called as head and start. Means when single linked list or any linked list is existed, the starting node, the start node always not pointing to null, always pointing to some of the node. Is it right? Is it right?
Yes, sir.
Means when I am creating structure, the start I assigned initially the structure is null. That's why I assigned start equal to null. Means initially what happened? Start is null. If the start is null means there is no node, it is going to start is pointing to whom? Null means not defined. Not defined means there is no single linked list. Are you clear now? Start is a pointer, it is always pointing to the first node in a linked list. Are you clear now? Here, how to define the list is empty or not? Only the case is here start is pointing to null, then you can understand oh list is empty. Start is not null, the list is not empty. Are you clear now?
Yes, sir.
Are you clear?
Yes, sir.
Yeah, please. So this is the main point. Now, initially, I am thinking maybe two cases, right? Already I told you. One is empty case, another one is non-empty case. If means no student is there in the class. So if I ask anyone is there in the class, What you can tell? What you can tell? It is empty. Yes or no?
Yes, sir.
If single student also there, you can tell what is the start means. That roll number you can tell. Means you are not going to tell singular 3, 4, 5. Just you are going to tell start is there or not. Are you clear?
Yes, sir.
Now, two cases. Then we have to write two cases in this program. That's why I am taking if else statement. If start equal to null. So if start equal to null means what we are going to check here? We are checking that start is null. If the start is null, what is the meaning? What is the meaning? Start is pointing to null. What is the meaning? If it is true, what is the meaning? If start is null, what is the meaning?
There is no single
List is
linked
empty.
list.
Linked list is empty. Yes or no?
Yes,
There is
sir.
no single linked list existed. Here, if it is going to return this if statement true, then the meaning is the single linked list is not existed. Start is pointing to null. No node is existed. If you want to insert any node, that node is going to, you think like this. If no node is there, for example, in your classroom, no one is there. Now you are going to enter into the classroom. Who is the first person? Before entering in your class, no student is there in the class. Now you are entering into the classroom. Who is the first person? Who is the start node? Who is the first person? Not clear. In your class, no student is there. You are going to enter into the class. Who is the first student?
It's me, sir.
Me.
Yeah, you are the first student. Now in a single linked list, there is no node. Now you are trying to insert a node at the beginning of the list. Yes or no? Beginning of the list or last of the list or middle of the list. Here no student is there. If you are going to enter, you are the first, you are the last, you are the middle. Yes or no?
Yes,
sir.
Anyway, you are the only one student. Yes or no?
Yes, sir.
If I am going to look from starting, you are the first. If I am going to look for last, you are the last. Yes or no?
Yes, sir.
Yes, sir.
Only one student is there. He is the first, he is the last in a class. Here now, if start equal to null means what is the meaning? Here now there is no single linked list is existed. If there is no single linked list existed, now I am trying to insert which node? A new node I am trying to insert as a first node, beginning node. Yes or no?
Yes, sir.
Now list is empty. If the list is empty, I am trying to insert this node as a starting node. Then which is the I am inserting this new node into the beginning of the list. Then what is the first node now? What is the first node? What is the start node now?
NN.
Yeah, NN is the start node. Are you clear? Now just you have to write start equal to NN. Start equal to NN. Now start is pointing to NN, right? So start equal to NN. Now start pointing to NN. Now you know single linked list always start from where? Start node, first node. Yes or no?
Header. Yes, sir.
I am taking here start my name. You take header. Someone will take first. Okay, what that names is you can define. I am taking in the entire my program. I am going to take start node, please. Okay. Now always the single linked list always start from first node. You can call as it is a start. Okay, that's why how it is single linked list looking. Here always the node is divided into two parts. S part is there. This is the start node. This is the last node. That's why this node is next point is pointing to null. Are you clear? This single linked list contain only one node. Are you clear this?
Yes, sir.
Are you clear, everyone?
Yes, sir.
Yeah, good. Right. Now, okay, this is the first case in the inserting beginning. Now, what is the next case? Next case means list is existed. Are you clear now?
Yes, sir.
List is not existed. Your new node work as a first node, start node. Yes or no? Your new node convert as a start node. Is it clear now?
Yes, sir.
Yeah, I shown logic also. Right. Now there is already the list is exist. I don't know how many nodes are there. For example, just I am drawing, but I don't know how many nodes are there. N nodes are there. One node is there. 20 nodes are there. 50 nodes are there. Okay, we don't know how many nodes are existed. Just I am assuming maybe 3 nodes I am assuming, but I don't know. Maybe it is 20, 30, 40, 50, 60, 100 nodes. That is not a issue. Yes or no? Are you clear? What I am telling, are you clear?
Yes, sir.
Yes, sir.
So, this is pointing to none. Now, in this single linked list, what is the start node? This is the start node. Yes or no?
Yes, sir.
Yeah. And now in this code, if this condition is fails, if start equal to null, means when it is going to fail, when start is not pointing to null, this condition is going to fail. Yes or no?
Yes, sir.
When it is going to fail, it is going to out of the loop, means it is moves to the else. Yes or no?
Yes, sir. Yes, sir.
Else means what is your thinking? Always, why should I return else? First, if and means always you have to take negative first. Then remaining all are positive. That's why always my programming and my explanation always in a negative first. Means there is no single linked list is existed. Only one case. Only one, right? So remaining all are under else part. Then we are don't worry about that. Remaining all are. If you feel no, sir, I want to write first else part first, then you have to think more things. So that's why always I am going to think in a reverse direction. Then our programming writing is very easy. Please. Okay. Now list is existed. When list is existed, now your new node is like this. Yes or no? Already new node is created, right? Here, top. So we are created, right? New node. Yes or no?
Yes, sir.
Here, new node already created. If list is empty, you are going to use this new node here. If list is not empty, we are going to use this new node in this logic. Logic is very simple. Clear? We are not going to use in the two cases because it is if and else block. In this if and else block, we are going to, our compiler is going to work with only one of the logic. If condition is true, then it never execute else part. Yes or no?
Yes, sir.
If condition, if it is out of if condition, it never execute if condition, it must move to the else part. Is it clear? Is it clear now?
Yes, sir.
Right. Now we are in which block? Else block.
Else.
Why? Because list is existed. Clear now this point? Clear now this point? Yeah. Now, here where you want to insert this new node? Where you want to insert? Beginning of the single linked list. This single linked list, how many elements are there? We don't know. Maybe one element is there, two elements, three. That is immaterial to us. Because start is not pointing to null. That is only the material. Because we are going to insert this node as a new node. Is it right or wrong?
Yes, sir.
Yes, right. Very good. Now the logic is very simple. We are going to connect this node to this first node. Then you make it this new node as a first node. Correct? Start node. Is it right?
Yes, sir.
Then how to connect? The connecting is very simple. Sure, you know already new node, you know already start node. These are the 2 pointers we have. No need to worry about this. Are you clear? Understand? We know NM. What is NM? This 10. You know start. What is start? 20. You know. These 2 things you know, right? Already. Because we are already having pointers for this NM new node and pointer for start node. Clear? Clear?
Yes, sir.
Now, if it is clear, now then what is the logic? Just this new node you have to connect it to the first node. Yes or no? Yes or no?
Yes, sir.
Now, how to connect? Tell me. Simple. Here, NNXT is null is there actually. What it is? NNXT is what? Null, right?
Yes, sir.
Yes, sir.
So means it is not connecting to anything. Now, what should we do? NNXT, we have to connect to the start. Then what should we write? NNXT equal to start. You must assign, instead of null, you must assign NNXT equal to start. So NNXT equal to start. Now this NNXT contains what? This NNXT contains what?
Start.
Start. Now we are connected this beginning of the list or not?
Yes, sir.
We are connected this beginning this new node beginning of the list or not? Everyone.
Yes, sir.
Yes, we are connected. Your job is done. But the problem is here always single linked list start from where? Always single linked list start from where?
Start.
Start from here only. Means if you are going to read the elements, if you want to display the elements in the single linked list, it is going to display from 20, then moves to 30, then moves to 40. Then it is going to stop because null is there. Yes or no?
Yes,
20, 30, 40. But we are added this new node before the start. That's why you have to make it
Start
your
equal
start
to
as
NN.
a NN. Then you write start equal to NN. Now this pointer is pointing now from here to here. Now this is a start. This is the statement start equal to NN. Start equal to NN. Now if you want to read the single linked list element, it is going to start from start. Means 10, 20, 30, 40. Are you clear this? Still any doubts? Are you clear this code?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Shall we go with the next insertion? Shall we?
Yes, sir.
Okay,
Yeah.
sir.
The same way you have to insert this new node as a last node. Are you clear the logic? This new node as a last node. Are you clear now? The meaning. Are you clear?
Yes, sir.
This new node you must insert as a last node. Clear?
Yes, sir.
Yeah. Now the thing is again. Now this is the case. What is the case? Inserting at beginning. Now I want to insert the node as a last node in a single linked list. Again we have to prepare. Already you have created structure of the node. Again we have to prepare the node and assign the value and assign the null. So this is common already told you. Are you clear? Are you clear?
Yes, sir.
Means create new node. Create new node means this is NN. Using struct node NN, you have to create. Are you clear? After creating, allot the memory dynamically. Are you clear? The story is same. Because this is another way, right? We are inserting. That's why you have to create. We are now created and enter the data. Now we are inserting the data in a data part and assigning null to the address part. Clear this? Up to this code is common, right? Yes or no?
Yes, sir.
Right. Now here I want to insert a new node as a last node. Here are also two cases. One case is list is existed, another case is list is not existed. Possibility is there or not? Two possibilities, right? List is not existed, list is existed. Correct?
Yes, sir.
Now if the list is not existed, means your new node as a first node as well as your new node as a last node. Yes or no? Because we want to insert your new node as a last node. As per the topic, the insert at end of the list. There is no new node. There is no student in your classroom. You are entering into the classroom. Maybe you are the first person, or maybe you are the last person. Is it right?
Yes, sir.
Is it right? Is it right?
Yes, sir.
Please, if you are going to understand, you please respond. Otherwise, you ask. Now then the list is empty. How we are going to tell the list is empty? What is the logic? What is the condition? What's the condition? How we
The
can
start equals to null.
if start equal to null? Means start is null, then list is empty. If the list is empty, then what should we do? Means there is no element. Then what should we do? If the list is empty, you are entering into
Start
the
equals
class.
to NN.
You are the first. This node is converted as a first node or last node because only one node. The only one student in the queue is the first person, is the last person in the same way. Okay. Now I am inserting beginning also same, last also same. Now I am going to assign start equal to NN. Is it clear now? Is it clear?
Yes, sir.
Here, next one is the else. Means the list is not empty. Means list contains elements. Here means that start is not pointing to null. The logic is very simple. The start is not pointing to null. Then it moves to the else part. Yes or no? If start is pointing to null, compulsory whatever the node you have created, that node new node work as a first node or last node. But when the list is not empty, means the start pointer is not pointing to null. If it is not pointing to null, means it is going to point into any node. Maybe that single linked list contains 100 elements, 1 element, 200 elements, that is immaterial to us. The point is very clear, the list is not empty. Are you clear? Are you clear this? Are you clear this? Yes or no? Yes or no?
Yes, sir.
Yeah. Now the list is not empty means the list contains some of the elements. Just I am preparing. The list is existed. Just I am taking. You can take 1 element, 2 element, 3 element, 10 elements. Not an issue. Okay, not a problem. Just we are going to add element new node as a last node. That is our task. How many elements are there is immaterial to us. Please remember this point. Always, always the last node next to pointer points to null. Correct? Yes or no?
Yes, sir.
Now this is always the first node points to start pointer. These are the two things you have to remember. First node always points to start pointer. Last node next to pointer must contains null. Maybe this is 1, this is 2, this is 3. Correct? Now this is maybe, you think this is maybe existed single linked list. Let's assume, just I am taking this assumption. Now my new node, how it is? My new node, how it is? This is NN. The data part is 10. The next is null. Correct? Is this correct? Are you clear? Is this correct?
Yes, sir.
Yeah. Now we are going to attach this new node as a last node because we are going to insert this new node end of the list. Correct?
Yes, sir.
But we don't know which one is the last node. Yes or no? But we know start node, we know NN. But we don't know the which is the last node, because we don't have any pointer to identify last node. Yes or no?
Yes, sir.
Now, then how to identify the last node? Tell me anyone. One logic is there as per the discussion. As per the discussion, one logic is there. Then how to identify the last node?
Last node always contains null.
Last node always contains null, or last node next pointer always
Yeah.
contains null?
Next pointer will always contain null.
Yeah, that is very important. The node which contains next pointer is null, then we can think that is a last node. Because I don't know how many number of nodes, just I am drawing here for our understanding 3 nodes, this structure, but we don't know, right? How many nodes are there? Only one node is there, 2 nodes are, 8 nodes are there. But we have only the pointer, start pointer we know, and an end pointer for new node we know. But I don't know which is the last node. Only we can understand only based on the node which contains next pointer is null, then we can decide that is the last node in a single linked list. Is it clear? Is it clear?
Yes, sir.
Then how to find the last node? Sure, we have to move from start to last. Yes or no? Until unless the next pointer is null. Correct? Is it right?
Yes, sir. Yes, sir.
Now we are moving from start. Start equal to start next. Start always the start next is not null. We have to take the condition while loop. Start next equal to null. So this is the start next pointer, right? This is the start next pointer. It is null. Is this pointing to null?
No,
Is this
sir.
pointing to null?
No, sir.
No. Then if it is no, we move to the next node. Yes or no?
Yes, sir.
Then the start is next is null? No. Then move to the next node. Then if it is null, yes, it is null. Then we can understand, you stop your iteration, then you can understand this is the last node. Yes or no? Because this next is null. Now you know the last node and you know the NN. Then you can connect. After identification of the node, you can connect the nodes is very easy. Is it right or wrong?
Yes, sir.
After identification of the node, the connection is very easy, right? Just you have to assign the address. But identification is the problem now. Now, how to identify? To move in a single linked list from start to end. End means the node which contains next pointer is null. Until that, you have to move. Is it right? Is it right?
Yes, sir.
Yes. Now, if we are using the start pointer directly, if we are going to move from here to last, after connecting from here to here, then which is the start pointer we are moving, right? Start pointer from here to here, from here to here. Start will come here. Yes or no? Yes or no?
Yes, sir.
Now you are connected. Start next equal to NN. Because start next is null, just you have written start next equal to NN. Yes or no? Connection is like this only, right? Start next equal to NN. Then automatically, instead of null, it is going to store NN address here. Now it is going to insert it as a last one. Yes or no?
Yes, sir.
But where is the start? Now, after connection, where is the start after connection? After connecting this node, where is the start? The start pointer is pointing to last but one. Yes or no?
Yes, sir.
But actually the start is here. Means it is going to represent beginning of the single linked list. But it is not connecting, the pointer is not pointing to here. When we are going to display, what are the elements is going to print after connection? What are the elements are going to print when I am going to display elements in a single linked list? Tell me, what are the list of elements after connection from the start to NN? How many elements are there in the single linked list? After this connection, how many elements are there in the single linked list? Are you understood my question?
Yes, sir.
Now tell me how many elements are there in the single linked list now? Are you following? Single linked list always starts from start only, correct?
Yes, sir.
Yes, sir.
Now, because of identification of last node, we are moved the start pointer until unless the next is going to null. Now the start is moved to last. Now the start is here. Now you are identified last node in a single linked list. Now start is moved from here to here. Start pointer is pointed to this node. Now we identified last node. Now this is the last node. This is the NN. Our job is to connect this new node to the last node. Then directly we can write start next equal to NN. Then this is connected. Instead of null, we have written NN address here. Then we are connecting this. Right after connection, how many elements are there in this single linked list? How many elements? Tell me if it is wrong, what is the thing? I am going to punish you. Then you can understand.
Sir, we don't know because the last node next.
My question is very simple. Here I identified this last node. After identification of last node, I connected this node to this. You take the connection is existing. Now tell me in this single linked list how many elements are there?
4.
The start is already moved, right? Now tell me. How many elements are there? In this single linked list, how many elements are there?
4.
No 4, yaar. Where we are going to start in a single linked list always?
2, sir.
2, sir.
Always you must start from start only. Yes or no?
Yes, sir.
Always you must start from start only. You start from here, we have to move until unless to find the null. How many elements are there in the single linked list? 2. But is this right?
No, sir.
No. Why? Because already we are allotted memory, already we are using memory, already we are created nodes. Here we are writing in a wrong statements. That's why here we are utilizing the memory, but we are not considering this data. Here this is a wrong, because here always the start pointer pointing to the first node in a single linked list. That's why don't move your start pointer. Don't move your start pointer. Please try to create a temporary variable and use the temporary variable. You move through the temporary variable. Please don't use this start pointer to move any pointer. Don't move. Always it must be connected to the first node. Don't move start pointer. Here, note it down. This point, because of this point, I have given this much story. Understand now the problem? Now understood what is the problem? When we are going to move your start pointer, this is very important. Always we are using the same thing to all data structure. That's why I am giving this clarification. Please, time is running. Tell me, are you clear this point?
Yes, sir.
Here, that's why instead of moving the start pointer, here I declared one more temporary variable start t as a struct node. Are you clear? Are you clear? One more pointer I declared, that is a start t along with NN. Clear now?
Yes, sir.
Now the T is which type? Struct node type. Then we can make it this T to any node, not a problem. That's why here in this else part T equal to start I assign. Now your start is this, right? T. Clear? Instead of moving of start, we take one temporary variable T to traverse in a single linked list to find the last node in a list. Sorry, this is a temporary variable. Instead of moving the start in a single linked list, you must use this temporary variable. Using this temporary variable, you can traverse in a single linked list and you identify last node. Are you clear now? Why temporary variable is required? Understood?
Yes, sir.
Yes, sir.
Yeah. Now use this T. Now T is there. Now how to identify same program, same logic, whatever I told you start in the same way you can write. Here T. Now T is going to point to the start node first. Now you have to check. T is not, T is next is not contains null. The T next is not contains null. If it is true, then you move T to T next. So this is the logic. While T next, here T next, this is the T next, right? T next is null. Is this, in this case, T next is null?
No.
No, because it is pointing to some node. If it is no, means we have to move next node, right?
Yes, sir.
Yes.
Because it is sequential, right? Sequential data structure. You must move to the next node. Okay, that's why T next is not equal to null. T next is not equal to null. You have to move to the next node. That's why T equal to T next. I have written here T equal to T next. Understood this point? Please
Yes, sir.
understand this. T next is not equal to null. Yes, T next is not null because it is pointing to something. Then you must move to the next node, next following node. That is the logic. T equal to T next. T equal to T next. Now T moves to here. Now again, come back. Because it is a while loop. So until unless it is going to fail, it terminates the loop. Otherwise, the loop is going to execute continuously. Right. Now again, T next is null.
No, sir.
No. If T next is not null, then we must be execute the following block. What is the T equal to T next? T is moved to the next node. Yes or no?
Yes, sir.
Yes or no? Now again,
Sir.
loop is going to execute. T next is not equal to null. T next is null or not?
Yes, sir. Null.
If it is null, this loop is not going to execute. This loop is out of the loop. Yes or no?
Yes, sir.
Right? Means if you are out of the loop, means you know T is this. We are going to decide that this is the last one. Yes or no?
Yes, sir.
Sir.
Because this node next is null. The node which is next pointer is null, then you can conclude that is the last node. Is it clear now? Even if it is 100 nodes are there, it is going to iterate 100 times. That last element, it is going to identify the loop is terminated, then you can identify the particular node is the last node. Are you clear now?
Yes, sir.
Clear now? Now you know the start. Now you know the T means
Null.
last node. Now you know the NN. Yes or no?
Yes, sir.
Now you know the last node. Now you know the new node. Because we are going to insert at end of the list. Last node. You must be insert this new node as a last node. Now you know the last node of the existing single linked list. Now you know the NN. Then what is the logic? The T next is null, right? Instead of null, what should we write? T next equal to NN. Yes or no?
Yes, sir.
Right. Okay, this is the statement. Out of the loop, T next equal to NN. T next equal to NN. Now this, instead of null, we are storing NN here. Now we are attached. Here no need to change anything because start is always start. Now how many elements are there in the single linked list? Tell me. Now how many elements are there? We are not moving start, right? Now how many elements are there in the
sir.
single linked list?
Four, sir.
1,
Four.
2, 3, 4. Here there is no any problem. Correct. Now you can understand why should we declare a temporary variable. Clear now?
Yes, sir.
Yes, sir.
Yeah. This is for insertion at end of the list. Is it clear?
Yes, sir.
One more operation is there, insertion, but still I missed 1040, right? Okay. Please practice these two things: insertion at the beginning and insertion at end. Okay. In the next class, we are going to complete insertion and deletion both the operations, because now everyone is understood these two. Because if you are very clear this, my job is going to reduce. Today also we discussed about previous topics. That is what I am asking. Everyone is clear this?